Good morning. Today we are navigating one of the most pivotal concepts in modern industry, the global automated transition. This is far more than a simple upgrade. It's a fundamental struggle between three competitive parts: the internal combustion engine, hybrid electric vehicle, and battery electric vehicle. These are not just different car types; they embody competitive vision for our future, each with major trade-offs in sustainability, economy, and equity. Our analysis today argues that this is a profound systematic challenge. The real conflict extends far beyond tailpipe emission and encompasses entire life cycle, industry disruption, and critical issues of ethics, safety, and community. Therefore, we will move beyond a synthetic tech debate. Our goal is to relieve why a successful transition requires a holistic and managed strategy for the entire automotive ecosystem. Let's begin by constructing the core conflict.
Thank you, Ain, for the introduction. Next, we move to the conflict. There are 6 conflicts that we found. We start with the first 3, namely environmental impacts, cost of ownership, and system complexity. Here, ICE shows that it has the highest carbon emissions. It is cheap but requires high oil and maintenance, and also has a simple engine system. HEV has less emission but still uses petrol. The price is medium and has complex dual system, while BEV is the lowest emission, expensive but simple mechanical. For the next 3 are performance and reliability, policy and market transition, and infrastructure. Here, ICE shows consistent performance but less efficient, more pressure on environmental policies, but the fuel stations are everywhere. HEV has performance different from the lab result, becomes a transition technology, and still needs fuel, while BEV has limited driving range, relies on government incentives, and limited charging stations. We move to the factors contributing to conflicts. There are 8 factors that we found. As we all know, ICE has the highest emission and pollution. Its energy source really depends on the global oil supply, but cheapest to buy and many fuel stations. And then HEV has a lower emission than ICE. Depends on battery and oil, medium price, and the availability not very different from ICE. And then BEV has the cleanest operation, depends on electricity, expensive, and the charging network are very limited. Next, in the terms of job and industry, ICE has millions of jobs, and the user prefers convenience and speed. For industry, for BEV, it needs many parts and services, relies on lithium or cobalt for the battery, and really has to plan trip and charging times. And HEV industry keeps both work but not fully stable. Sometimes avoid charging and using fuel.
Ethical issues arise from the fundamental of trade-off between the fuel and minerals. ICE car relies on a global oil market prone to deception and pollution. Conversely, BEV require intense mineral extraction, shifting to the moral burden to mining communities. Other than that, HEV attempt to balance this, but their complex nature often leads to greenwashing when real-world fuel efficiency fails to meet marketing claims. So, for safety risk stem from how each vehicle store and release energy. Firstly, ICE cars carry flammable liquids near hot surface, leading to frequent but predictable fire. BEV use high-density chemical cells that, if damaged, trigger self-sustain, which thermal runaway and HEV are the most complex, combining both pressurized fuel and high voltage system, statistically leading to the highest fire incidence rate. So for the next one, the health profile shift because we are moving pollution from the tailpipe to the tire and the factory. ICE vehicles harm urban lungs through exhaust and noise stress. BEV eliminate exhaust, but their extreme weight accelerates tire wear, creating toxic and road dust. Meanwhile, the manufacturing of BEV batteries expose factory workers to heavy metal dust linked to the chronic lung and neurological disease. We go to the community issues. Neighborhood change because transportation infrastructure dedicates social inequalities. ICE vehicles historically burden low-income areas with high highway noise and fuel poverty. The shift to BEV threatens to create a digital divide where luxury apartments get charges while renters face charging deserts. This makes clear air an exclusive amenity, potentially accelerating gentrification and social exclusion. One is the environmental issue. The environmental footprint depends on whether we prioritize a single car or the entire fleet. ICE vehicles are inherently wasteful, losing 80% of their energy to heat, while BEV solve this but start with a massive carbon debt from the water-intensive mining. This is why 6-to-1 hybrid rules is vital. By using limited minerals to improve 6 cars rather than just one provide a faster path to total emission reduction.
The conflicts between ICE, HEV and BEV technologies show us that major transitions are not just about better technology. Even when a solution like a BEV is clearly superior in the long term, it cannot succeed on the merit alone. It must overcome strong resistance from existing ecosystems such as field infrastructure, workforce skill, consumer habit, and political interests. Plug-in hybrid clearly illustrate this issue. Although they perform well in theory, many admit more than expected because users do not change them regularly. This proves that technology without supportive behavior, policy and infrastructure fails to deliver its promise. Real change requires parallel investment in education, regulation and also system-wide support. At the same time, compromise technology like hybrid play a dual role. They reduce emission in short term and ease customer anxiety, but they can also delay full electrification if relied on for too long. This is why transition technology must have clear limits and exit timelines. Ultimately, the shift towards electric vehicles is a lesson in managed change. Success depends on coordination, strengthening the supporting ecosystem, and guiding social and economic adaptation to ensure it's just a stable transition. The conflicts between ICE, HEV, and BEV technologies show that system transition are not just about the technology. While BEV are the long-term solution, success depends on aligned infrastructure, policy and human behavior. Hybrids helps in a short term but must be limited to avoid delaying full electrification and ensure economic stability, workforce adaptation and a equitable transition.
To conclude our analysis, we reach several imperatives. First, this is an ecosystem battle. The long-term benefits of BEV cannot overcome a century of inertia by technology alone. Second, human behavior is decisive. As seen with plug-in hybrid that are rarely tried, determine the theoretical benefit. Third, while hybrids are a useful bridge, they risk becoming a compatibility tool with the key policy signal to ensure the accelerate progress. Therefore, the solution is orchestration, not a single collapse. It requires parallel action such as binding best-out timeline, massive infrastructure investment, life cycle regulation like battery passport, and critical just nutrition for the workforce. Ultimately, the journey is not just from gasoline tank to a battery. It's a shift to a new challenge to a mineral ethic, grid resilient, and equitable access. Our goal must be actively manage the change with foresight and fairness, ensuring the path to sustainable mobility is as just inclusive as the destination itself.